So look at the question someone had. How to make copies appear behind an object and then disappear after a while. So I believe the problem or the question is something to do with drawing a trail behind your object. So you have a ball or something like it. It has a certain movement like this, and as it is moving throughout the sketch, there'll be a trail of objects that follow behind it. To get this trailing effect, we need to store some information about the object that we are moving around. So first up, we need to store a history of the positions. So if you go through here, this has a X position and a Y position, this mover object. We've been using X and Y positions, storing them as P vectors. So basically we are going to have an array of P vectors that store different locations. So this one, store this location, store this location, this one, and so on, until we have enough items in the trail where we can start deleting some. And all of these will go into some array. We're going to call this array history. Array. In Java, there isn't a really good way to dynamically add items to our array. So previously we've done an array like this where we have an int, give it a name, my array. Sorry, it has the 2 square brackets at the end. Int array, my array equals new array, new int array. Then you need to give it a size, so 10 or 100 items within that array. This is great when we know exactly how many items we want in our array, but in this case, you're going to start off with just a single object. Then you're going to go to 2 objects, then you're going to go to 3 objects, 4 objects, and then 5. The best way to make this happen when we don't exactly know how many items are going to be in an array at a given time is to use something called an array list. It's not too much different than the normal array in Java, but it gives you that flexibility. So how do we actually initialize an array list? I wrote earlier how to initialize and define an array. But an array list is a little bit different. You start off, instead of with the variable type, you start off with the word array list. A and L is capitalized in this instance. And we're going to say, we're going to put these carets, which are next to the M keys on our keyboard. Left caret, we need to tell it what type of variable is going to be stored, P vector. Then we need to name it just like any other array. We're going to name it history. We're not going to actually define it just yet, so semicolon. There we go. And in our main sketch, we will put mover, let's call this a snake, and void setup. Void draw. mover. We'll give it a location of in the center of the screen, so 200, 200. And we're not going to get into the draw yet. So each snake object needs to have its own history. So we're going to place this history array list within the mover class. So right below our initialized variables, we're going to put that line that I just wrote, array list, caret, p-vector, history. So we're going to do the same pattern like we did here, initialize or define the variable. Then we're going to actually initialize it with a value down here within the mover constructor. So we'll say history is equal to new array list p vector, and it takes a parentheses at the end. Basically the same pattern as we did up here with location. Name it, then provide it with a value. All right, I'm back. I have to splice together two videos, but no worries. So let's start with how to actually draw the different items within the array list. So within the display function in your mover class, we first need to loop through the items within the history array list and draw them all on the screen. So we're going to use a for loop. For int I is equal to 0, I is less than history.size. So history.size is the way that we calculate the length of this history array list. This is a little bit different than the way that we would do an array. So an array would be array.length without the parentheses, because this is just a built-in thing. But because array lists are a little bit different, a little bit more advanced, we need to make sure we use history or array list, whatever you call it, dot size. Then at the end of our for loop, we're going to do I++ to increment it to the next item, and curly brace. So the first things first, we need to actually figure out which item in the array we are working on. So I'm going to make a new p-vector variable. P-vector, this will be the current item within the array list that we are working with. In a normal array, we would say something like my array with square brackets, and we would give it the index number, so 0 for the first one, to access the data within the array there. But with an array list, we have to say the name of the array, history, dot get. Dot get will return the data within that slot of the array. And within our for loop, we're going to use the I that's changing values within this set. So whatever I is equal to, that's going to be the current item in our array that we're working with. So for each one, we need to draw it onto the screen. I'm going to leave a space here. We're going to do something in between, but first I want to actually do the ellipse function. We all know the ellipse function. First we need the x position, then we need the y position. To get the x position, I'm just going to say current.x and current.y for the y position. Then we can do something like, for the mover class, I believe it is 20 times mass. So we calculate a random mass value here. Depending on the mass, it changes. I'm just going to be consistent with what is default. You all can change this however you want based on the item that you're making. So if you want to change the opacity, how see-through the item is, I'll show you how to do that. So first we have a fill value. Fill with a red value. Let's just say 255, a G value, so I don't know, 100, and a B value, 100. The fourth value here is actually going to be the opacity, how see-through or opaque this item is. If this ranges from 0 to 255, just like a color, 0 being totally see-through, and 255 being totally not see-through. So for the first item in our array list, that's going to be the farthest one from our moving object. We want that to be the most transparent. So if we do I times 20, that should give us a good range of transparent to totally opaque. Close off our curly brace, and that's it. That's how we're going to actually draw the items to the screen. But we also have to add new items each frame and delete ones that are too old. Next, we'll go to the update function of our mover class. So in update. Within the update, we need to add new vectors to our array list. And we'll also need to check if the array list is a certain size, delete the oldest item in our array list. I need to make a new p-vector variable to store our object's current location. Because we're going to add this item to the array list, we can't actually add the p-vector that's doing our calculation, like our velocity calculation, because that's being used. We need to add a totally new vector that's not necessary to our program. So I'm going to make a new vector, p-vector, name this one v, can be anything, equals new p-vector location x dot x and location dot y. Next, we need to actually add it to our history array list. I'm just going to say the name of the array list, history dot add, and I'm going to add this v vector. Once that's done, we can actually check if the size of our array list is greater than some number, then remove the oldest item in the array list. So we all know if statements. If history dot size is greater, missed the parentheses. Size is a little bit different than length. Is greater than, I'm going to say 20 for this example, but you can choose whatever you want. So if it's greater than 20, we're going to open up our curly braces. And within this, to remove the oldest item in our array is just history dot remove. Voila, that's it. Let's actually add this to our code. So first in the display function, I'm going to say for int I is equal to 0, I is less than history dot size I plus plus. Curly braces. Within here, we need to set a new p-vector to our current position within the array is equal to history.get. And when we go through our loop, I is going to be equal to the index that we want, so just I. Next, we need to actually fill it. Fill, I think it's at 255, 100, 100, and I times 20. We're going to see what this opacity level gets us. Finally, we're actually going to do our ellipse function, current.x, current.y, 20 times mass, 20 times mass, and that's all we need to do for the display function. Within the update function, let's add in the last thing, create a new copy of our location. P vector v is equal to new p vector location.x, location.y. Then we actually have to add it to our history array list, history.add v. Next, we need to check if the array list is a certain length. Delete the oldest item. If history.size is greater than 20, history.remove. Let's see if this works. Oh, you need to remove the oldest item, so 0. I forgot to write that in earlier, but no, you'll see. Let's run it. And, ooh, I didn't do anything in here. So we need snake. Oh, it's not moving. We have to give it a velocity. The current mover class has a velocity of 0. We could do something like p vector wind. Wind is equal to new p vector to 0, and snake dot apply force wind. Let's see what happens. There we go. And that's all there is to it. There's now a trail, and it fades out as it goes behind it. We're going to put this up on YouTube. If you have any questions, just leave it in the issues, leave a comment in the issues, and I will help you out.